Okay, so let's go a little bit farther with acceleration. We need to talk about the direction of acceleration. And that may sound a little funny at first, but remember that acceleration is a vector. Remember, vectors have both magnitude and direction. So acceleration does have a direction, but be careful. A lot of people don't understand exactly what that means. We can understand when motion has a direction because something is moving to the left or to the right. But you need to understand that the direction of acceleration is not the same thing as the direction of motion. That is not what we mean. Not only is it not the same thing as the direction of motion, it is also not simply speeding up or slowing down. Many people inaccurately assume that if you see a negative acceleration, for instance, they think that automatically means that something is slowing down if the acceleration is negative. That's not necessarily the case. It could be, but it's not necessarily. Same thing with speeding up. Many people assume that a positive acceleration automatically means that something is speeding up, and that's not what that means. It could be, but it isn't necessarily. The positive and negative does not indicate speeding up and slowing down, and it doesn't indicate the direction of motion. What it indicates is the direction of the change. Remember that acceleration is a change in velocity, and as you'll see in a minute, that change actually has a direction. It's the direction of the change. One really good way to see the direction of that change is to think about the force that's causing that change, because the direction of the force causing the acceleration is always a dead giveaway for the direction of acceleration, because the direction of the force is the direction of acceleration. Now, before we get into this, you got to remember, we've said this before, remember that anything moving to the right is a positive direction, left is a negative direction. So remember that as we talk about this. All right, so several examples. I call this example the rope illustration, the rope example. So it says up top, think about the force required to cause the change in speed, because the direction of that force is the direction of acceleration. All right, so let's imagine that we have a person in a wheelie, in a rolling office chair, and that person is going to roll to the right. We have a person on the left that has a rope, let's say a big long bungee cord rather, that's attached to that chair, and they're going to pull on that bungee cord to change the speed of the person in the chair. So in the first example, the person in the chair is already rolling to the right, and the bungee cord slows them down to a stop. Do that again. Already rolling to the right, and the bungee cord slows them to a stop. This person is accelerating. This is acceleration, right? So in this case, the direction of motion is positive. The velocity is to the right, right? Not only is the person moving to the right, they're also slowing down. Their speed is decreasing. So we now have to think about, what direction does the force have to be applied in order to cause that acceleration, in order to slow that person down? Well, it's fairly clear to see that this person is directing the force to the left. We have to pull to the left as the person is traveling to the right to slow them down. The direction of the force is the direction of acceleration. Since left is negative, we're going to call this negative acceleration. Now notice, this person is slowing down, and in this case it is negative acceleration, but the negative part doesn't tell us that he's slowing down. The negative part tells us about the direction of the change, the direction that the force has to be directed in order to cause that acceleration. So once again, person moving to the right, force directed to the left to slow them down, to decrease their speed. Since the force is directed to the left, it's a negative acceleration. Let's do a different example. Person this time is still going to be moving to the right, but now the person who has a hold of the bungee cord is pulling in a different direction. And as you can imagine, if the person pulls to the right, it's going to cause the person in the rolly chair to speed up. So in this case, velocity was in the same direction, still moving to the right, but now instead of slowing down, this person in the rolly chair was speeding up. Their speed was increasing. In order to do that, the force had to be applied to the right. Since right is positive, this is positive acceleration. Again, this person happens to be speeding up, but the positive in the acceleration doesn't talk about whether or not they're speeding up and slowing down. It talks about the direction of that change. The change is directed toward the right in a positive direction. That's the direction of the change. Another example. Let's say now the person in the wheelie chair is moving to the left, but they're going to slow down. So velocity is toward the left, and speed is decreasing, well, what direction does the force have to be applied to do that? Fairly clear that the force is applied to the right. And in this case, since right is positive, make your guess, acceleration is positive. Again, the direction of the force gives the direction of acceleration. That's the direction of the change. The force has to be applied to the right in order to slow this person down. So if you think about with any object that's slowing down or speeding up, if there's a rope or a bungee cord attached to that object to slow them down, the direction that the rope or bungee cord is pulling is the direction of acceleration. Last example, person in the chair still moving to the left, but now the person that is holding the bungee cord is on the left side pulling to the left. In this case, the person is going to speed up. So velocity is to the left and the speed is increasing, speeding up. In order for that to happen, this person has to apply the force to the bungee cord to the left. Left is negative. Therefore, this is negative acceleration. Notice in this case, negative acceleration causes increasing speed, causes the object to speed up. So this is flip-flopped, right? Negative doesn't always mean slowing down. And in the previous example, positive acceleration means slowing down. It doesn't mean slowing down, but in this example, there was decreasing speed even though the acceleration is positive. So the acceleration is all about the direction of the change, the direction of the force that must be applied to make that change, right? Whatever direction the force is applied, that's the direction of the acceleration. Now, there's another way to think about this. Oh, here we're going to do it again. There's another way to think about this, right? If that confuses you, that's okay, because there's another kind of non-abstract way to think about this. And all you need to know is two things. You need to know the direction of motion of the object, which we talked about in the previous examples, and whether the object is speeding up or slowing down. Those two pieces of information will help you to find the direction of acceleration. Again, we talked about both of those in each of the previous examples. And if you know that, you can figure out the direction of acceleration. So if we look at this table, here's your two pieces of information: direction of motion and whether the object is speeding up and slowing down. Now, if you look down here, I have positives and negatives. Those are, maybe I should have put those in quotes. Speeding up and slowing down isn't really positive and negative in terms of direction. But for this example, we can kind of consider speeding up to be positive, quote unquote, and slowing down to be negative, quote unquote. So in the first example, if the object is moving to the right, the direction of motion is positive. If the object is speeding up, that's considered a positive. And what we will do is now just say, well, what is a positive times a positive? A positive times positive is positive. That would be positive acceleration. And that works with our rope illustration too. In the example where the chair was moving to the right and speeding up, let's think about this. What direction does the bungee cord have to pull in order to speed that person up? Has to pull to the right. Positive acceleration. Next example, moving to the right but slowing down. Slowing down we consider a negative, and a positive times negative is negative. That would be negative acceleration. Again, it plays right into the bungee cord example. Moving to the left in the next example. If I'm moving to the left and speeding up, considered a positive, negative times positive is negative. That would be negative acceleration in that case. And the last one is the one that most people don't get right. If an object is moving to the left, that's a negative direction, but slowing down, we also consider that negative. Negative times negative is a positive. Negative times a negative is a positive. So in that case, it would be positive acceleration.